guys, good morning. Welcome to Aerospace Structure Lecture Series. Today we are going to see a design thinking based approach on aircraft structures and its evolution from aluminum material to the carbon fiber material. So here we are going to implement the 5 stages of design thinking by using the Stanford University's methodology. Students are going to explain here.
By emphasizing the case study aluminum to carbon fiber, first we have to look at the current industrial state. First of all, the mindset of the airlines would be lower operating cost and higher fuel efficiency, and in the view of manufacturers, competitive or lightweight durable material they want, and in the view of passengers, they expect safety, comfort, and they have to move one place to another by lesser time. They are time bound. And in the view of regulatory bodies, they demand strictly safer compliance and sustainability over the aircraft. In older days, aluminum is the one and only material which gives lightweight and high strength to weight ratio. But on current days, fuel cost and emission concerns and maintenance are really a big concern to search for a new material.
So we start the design for this from aluminum to carbon fiber composites. The core problem for this has been the modern aviation is adapting for their outer to their new level. So they start from the fiber composite materials. For the required questions are they need to for lower weights and the supreme life cycle, fuel efficiency, fatigue and corrosion. For this, the fatigue and corrosion had plays a major role in the further routes of the and completely dominates towards this whole problems. And the supremacy of life cycle and fuel efficiency. Comparing from the aluminum to carbon fiber compost, the supremacy is even more higher and also as weightless to maintain our fuel consumption very efficient to throw that. So these are the problems and the limits on their aerodynamic shape flexibilities. So the carbon fiber composite have some flexibilities towards the modern aviation, adapts from the supremacy to dominates towards the whole defense of air.
Guys, the idea for exploring material in the lesson for aluminum to carbon fiber composite, the structures for aluminum to carbon fiber, the exploring of alternative, CFRB for explain the carbon fiber reinforced polymer, and next for glass fiber and the armate cavern and hybrid composite that will use the exploring of alternative future materials for graphene composite and nano-and materials and synthetic structures for traditional fiber and constant aluminum skin is a bonded monolithic composite panels used for the aluminum to carbon fiber composite.
In this case study, design thinking approach to evolution of aircraft structure from aluminum to carbon fiber composite. We have seen the prototyping part. In this part, we have to redesign the structural changes. In this part, and the components, the stress and the fatigue will morely. So we have to redesign this component, these parts by the digital tool FEA, finite element analysis. In this analysis, we analyze the stress and fatigue of the part. After the analysis, we have to assemble the piece by piece. We have to mesh the component into the small parts, and we have to assemble the small part piece by piece into the large component, into a single large component.
Okay guys, now we are going to see the test part of this case study.
evolution of aircraft structures from aluminium to composite carbon fibers. To conclude this, we can approach two different scenarios. In first scenario, we can take the Boeing 707, which is made of aluminium core, and that gives design simplicity and it gives a flexible design. On this case, it's a very classical case. And then coming to Boeing 787 Dreamliner, it's in composite era. By adding composite materials like carbon fiber, we can reduce 20% fuel, and then we can save 20% of fuel, and then we can reduce corrosion because the carbon fibers are not exposed to corrosion. And then the other point is we have smoother aerodynamics than the aluminium used because the carbon fiber is very smooth in surface. These are the advantages of using composite materials instead of aluminium. By concluding that, we can conclude that aluminium is only used for best cost savings and design simplicity. Aluminium is used for that purpose only. By using these composite materials, we can attain these type of advantages. So aluminium also is good, and we can also to add some extra features to add some cost savings. We can use composite structure.